The vapor pressure of water at particular temperature is given. Calculate the vapor pressure of water when 25 gram of glucose is dissolved in this one. So now this one is very easy because this one, it means here, vapor pressure of water, it is given, there is nothing dissolved. So this one is actually P1 naught. Why I normally write 1 here? Because 1 designates solvent. That's why. Okay. So P1 naught. And when it is dissolved, we have to calculate. So means P1 naught is given 17.535 mmHg. P1 we have to calculate 25 gram of glucose. Glucose 25 gram means it is W2 25 grams in 450 grams of water means W1 is 450 grams. So you just need to substitute it in the formula and you will get the value answer. So formula based question, this one. So this one formula will be P1 naught minus P1 divided by P1 naught equals to, you can just say it is approximated value. So if it is approximated value, you can write it as W2 into M1 divided by W1 into M2. Okay, or you can write here W2, right? Okay. M2 here, W1 here. It is actually X2. So if anyone is confused, it is actually X2, which will be N2 divided by N1 plus N2. What I am saying, I am doing approximation. So here I am neglecting N2 as compared to N1. So I am writing just N2 by N1. So if I write N2 by N1, this will be W2 by M2. This will be W1 by M1. So that's why I had written W2 into M1 divided by M2 into W1. From there. However, you don't need to write everything. You just can write equal to this one and substitute the values, get the answer. So this is now just you need to get the answer after calculation. So I'm not doing the calculation. Once you do, you will get P1, which you have to calculate as 17.438 mm of Hg. Now another point, mm of Hg is also known as torr. So if you get the unit of pressure written as torr, it means it is these many mm of Hg. Next one is Henry's law constant for the molality of methane in benzene at 298 Kelvin is given. Okay, so KH is given. Calculate the solubility of methane in benzene at this under 760 mmHg. So again, this is basically
the previous slide.
Yes, 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 one is here. Utkarsh, yes, correct. Just another way to write it. Okay. Okay. Understand the concepts. Okay. All the concepts. Now, this is something related to where we considered in this question, where we considered molality as concentration. And you remember in solubility, we considered concentration as the solubility. So understand what we have been doing. We will be collating those information, those details to get the answer here. Here the question says the Henry law constant for molality of this is given. So KH is given, and calculate the solubility. Solubility is nothing but S, which is actually the molarity. Okay, but in these cases, molarity and molality will be almost the same. So in these type of questions, you have to remember you will be doing approximation. Okay, solubility is actually molarity, but it is approximately molality. So if you are asked to calculate the solubility, you could have calculated molarity, but in the formula which is there, P equals to KHX, okay, the mole fraction. Well, how you can change it so that you get the molality or molarity or the concentration? How can you change it? Now remember, this one is given in mm of Hg. This is given in this is given in mm of Hg, and this will not have any units. So obviously pressure will have unit of this mm of Hg. So this should be the mole fraction in that case. So if you know the mole fraction, is there any way to get the molarity, the concentration here, which is our solubility is molarity? Can you get that? How do you get that? Anyone? Question is talking about calculate the solubility. I have given you the answer that you actually need to calculate the molarity. How can you calculate the molarity in such cases? And the reason is you have not been given anything about, the mass, the volume, nothing is given. So in this particular question, okay, I have received one answer.
Since
Okay,
pressure is given, first we should take out the mole fraction, sir.
Okay, then remember this pressure is given. This is given 760 mm of Hg, and kh is also given in mm of Hg. So it means you don't need to change anything. Both are in the same quantity, and this is x here. So in such questions where nothing is given and it is written Henry's law constant for molality of methane is there, then in that case, you will consider that whatever we are talking about concentration, we are talking about the concentration for molality. So whatever Henry's law constant for molality of methane, so means methane is the solute. Methane is the solute here, okay, and this is the mole fraction of solute. So we will consider it as a molality, that is concentration, that is solubility. So understand what change you will make here. If it is written nothing is given, so actually it is impossible in that case to calculate the molality unless something is given for that. So there is a hint here. This question says Henry's law constant for molality of methane, not the mole fraction or concentration. Specifically, it says for molality of methane. So it means whatever you will consider this mole fraction is in such a way in that it is actually molality. So remember, you will change in all these questions, you will change this X by C, which is actually molality, by M first. But here, by approximation, this molality will be equal to molarity, that is C or capital M you can write, and then molarity is solubility. So you will first not change by C, you will say it is actually KH into M. Whenever you have this sentence, Henry's law constant for molality of methane, you will use this formula. Instead of P equals to KH you will say it is P equals to KHM. The reason is, in that case, instead of mole fraction, we will be talking about molality. So here it will be actually not X, here it will be C. And you will get the answer. Otherwise, you cannot get the answer in all such questions. Very specific type of questions, okay, only this specific type of questions will be there. I will be talking about one more exception, and when we started these questions, I said at the very beginning that I will be talking about two exceptions. So this is one. Another one is, which will be there later on, we will be doing. Another one is that you will write the formula on the basis of the unit of KH. So in few cases, and I would say that in exam, you should be careful that if a unit of KH is not the unit of pressure. So I'm repeating it, and it has happened a few times in board exam. Normally, if you say P is equal to KH into X, this X is a mole fraction. And because it is mole fraction, fractions do not have any unit. So it means both of these will have same unit. So unit of KH should be in the unit of pressure. So no units here. And this one will have unit of pressure. But you will see in few questions which have appeared in board exam, this KH unit is not ATM or bar, not unit of the pressure. So in one case, it was actually per mm. So you will write the formula like that. In that case, you will write 1 by P equals to KHX. Only in those cases, this is the exception. So understand the exception. You will see the unit of KH. If it is not of the pressure, you will modify the formula That is, instead of pressure, if the unit is per ATM, you will change it to 1 by P. It can be anything, okay? I'm just giving you an example, which has happened in board exam. And I will be doing that question, so don't bother about that at the moment. So here what I did, if I apply KH equals to X, I cannot get the answer. Then I see it is written the molality of methane in benzene. It means instead of X, I will put M. And by approximation, molality and molarity will be same. So I will say C. And this is what I have to calculate. Solubility S is C. So C will be 760 divided by 4.27 into 10 to the power 5. Whatever you get, that will be the answer. You will get answer as 1.78 into 10 to the power minus 3. And because it is solubility, it will be mole per liter. 100 gram of liquid A, molar mass given, 1000 gram of liquid B, molar mass is given. The vapor pressure of pure liquid B, this much torr, means liquid B, if we consider as solvent, okay, 1000 gram, if we consider that solvent, will be P1, the vapor pressure, yes, P1. Calculate the vapor pressure of pure liquid A. This is P1 naught, okay, so this is P2 naught. And its vapor pressure means P2. In the solution, if the total vapor pressure of the solution is, this is P total given. Now these values, by looking onto these values, you should have realized that we are going to use the formula of P total. Okay, so P total is equal to P1 naught, and you can say P1 plus P2 first. You can use the formula directly. I am writing just to make you understand. Okay, P1 naught X1 and then P2 naught X2. P total is given 475 torr. Okay, P1 naught is given 500. So I'm using this one, 500 into mole fraction. I have to calculate. Obviously, you can calculate mole fraction because 100 gram, its X1 will be 1000 gram divided by 180 gram. Okay, so N1 will be this one. So N1 equals to given mass divided by molar mass 180. N2 equals to given mass divided by molar mass. Remember, I am considering N1 as the liquid B. Okay. Or if you want to remove confusion, I'm just changing it, right? To remove the confusion, I will be using A and B because it is given A and B. I will say P total is equal to PA naught into XA plus PB naught into XB. Okay, this will make life slightly easier. So I will say XA is equal to given mass 100 divided by molar mass. Sorry, NA, not XA. And NB will be given mass of B divided by molar mass 180. From here, I will obviously calculate the XA and XB. And then I will get the answer. So XA, if I calculate, XA will be NA divided by NA plus NB. That is, you will have to do calculation. I'm not doing the calculation here, okay? So once you get the XA, XB will be 1 minus XA. Okay, so you will get both these values. Everything is given except what you have to calculate, the vapor pressure of A. That is unknown. So here you have 475 torr given. PA naught you have to calculate. XA you will substitute from here, okay, into XA plus PB naught. PB naught is given 500 into XB you will substitute from here. So only unknown is PA naught, which is asked. You will calculate PA naught. Once you know PA naught, okay, so PA naught will be something you will get. After that, you will calculate PA. PA will be PA naught into XA. Because that is also asked. vapor pressure also. Okay, calculate the vapor pressure of pure liquid. So pure liquid will be PA naught, and vapor pressure normally of the solution will be this vapor pressure of A in solution. Any confusion here? From here you will get PA naught. Once you have PA naught, you can get PA. Next one. This question I will just give you an idea of, because this question cannot be asked. Okay, this is slightly very time consuming, so will not be asked because you will have to do many calculations, but it actually helps you to understand the concepts only. So vapor pressure of pure acetone and chloroform at some temperature are 741.8 and 632.8 mm. So pure given, both chloroform, acetone and chloroform. Assuming that they form ideal solution over entire range of composition, plot P total, P chloroform, and P acetone. And you remember, this is something we are talking about where it was something like this. P total was like this. Okay. I would say first, say P1 is like this. If P2 is like this, then P total was like this. Okay, so this was P total. This was say P1. This was say P2. You are able to recall that. So it is actually, this question is asking to draw that graph. Okay, so P1, P2, and then sum of those two will be P total. This graph is required with these values. So P acetone for this mole fraction, when X acetone means acetone's mole fraction multiplied by 100 is this much. Sometimes students get confused when these type of values are given. It actually means the mole fraction of acetone, X acetone, is 11.8 divided by 100. This is the actual value. This value 11.8 is when the mole fraction of acetone has been multiplied by 100, then you get this much. So it means X acetone is actually 11.8 divided by 100. So you will use these values, okay, and then you will plot the diagram. How you plot that diagram? So what will be the value of P1? P1 will be, say acetone, will be P1 naught X1. So you will multiply all these X1 here by P1 naught. So you will get the value of P1. Okay. Similarly, you will get the mole fraction of chloroform also. Mole fraction of chloroform will be 1 minus this value. Whatever you have here, 1 minus this value. And for that, you will get P2 equals to P2 naught X2. X2 is given. X2 you have calculated. Okay. X2 will be 1 minus X1. If this is X1. X acetone, if I am taking as 1. X2 will be calculated and P2 naught is again given. P2 naught is given. All these values pure are given. So remember, this question you have to do because I want you to understand the logic, but you will not do everything because that is very time consuming. So what you will be doing, you will be plotting only these ones which I am leaving. So you will not plot these. You will not plot these. You will plot only these 4 ones, remaining ones. So if you want to note down these values which you have to plot for 11.8, 36, 58.2, 72.1. So this question is there. You have to do in assignment this question, but you don't need to do entire values. Go through the notes if you want to understand that graph which I mentioned. And how do you get the value of P1? How do you get the value of P2? I have explained. P1 naught and P2 naught are given in the question. These are the values given. X1 is also given. This is the X1 value, X1, 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 X1 divided by 100. Remember, when you subtract it from 1, you will get X2, 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 X2 respective. So you get X1 also, X2 also. So you have to draw the diagram, the graph with respect to X1 and X2. X1 and X2 are on X-axis, P1 and P2 on Y-axis. P total obviously will be on Y-axis. Next question. Benzene and toluene form ideal solution over the entire range of composition. The vapor pressure of pure benzene and toluene given, pure benzene given, pure toluene given. Calculate the mole fraction of benzene in vapor phase if 80 gram of benzene is mixed with 100 gram of toluene. Read the question before I start explaining. Now see, start from the last. Calculate the mole fraction of benzene in vapor phase. If you want to calculate the mole fraction of benzene in vapor phase, what is the formula? The formula is P benzene, okay? It is benzene and toluene, so I'm writing B and T, okay? B for benzene and PT for toluene. PB will be equal to PB naught into dot, or you should say P total, okay? Into YB. YB in vapor phase. So this YB you have to calculate. This is total vapor pressure. This is, I should write total, okay? Because in this formula, this is P total. So this is what you will be using. So first find out what formula you have to use and what are the unknowns. So you need PB and you need P total to get the mole fraction of benzene in vapor phase. That is what you need. R1 P naught equal to, yes, to get P total, we will be using that formula. Okay, correct. So these two are unknown. Basically, everything is unknown at the moment. You don't know YB. This is something you have to calculate. You don't know PB. You don't know P total also. So you have to get PB. And PB will be what? PB will be, what is PB naught into XB? What is the difference here? This YB is mole fraction in vapor phase. And when you use this formula, this XB is mole fraction in liquid phase. So from this formula, you will get PB because PB naught is given and XB you can calculate. So you will calculate PB from here, you will substitute that one. How do we get P total? For P total, we have the formula that P A naught, or we will say P A. Okay, toluene I am considering as A. Okay, toluene I am considering as A. Benzene I am considering as B. Okay, so it will be PA naught into XA plus PB naught into XB. That will be the P total. This P total you will substitute from here and you will get YB. So always initially, because I know initially you will not be able to solve these questions very quickly, always try this approach and then slowly you will be comfortable with it. First write what is asked, see what are unknowns. Those unknowns you need to get first and you will get the answer. So what you will write here? PB naught benzene is given the vapor pressure of pure benzene and toluene, this one 50.7. So 50.71 mm of Hg into XB. For XB, obviously you will have to calculate the mole fraction. 80 gram benzene is in 100 gram of toluene. So how do you calculate? NB will be 80 grams, 80 divided by total. Okay, number of, the molar mass of benzene is 78. Okay. And then you have Na as toluene. Toluene will be 100 gram divided by its molar mass. Molar mass will be 77 plus 13. 15. 92. Okay, so it will be divided by 92. So from here you will get XA and XB. From here, you will get XB and you will get XA. And those values you will substitute here, here also. So this XB you will substitute from here. I'm not solving everything. You have to do this in your exam. So make sure that you solve all these questions yourself. And then you will substitute the value of XA and this XB. PA naught, PB naught are given. Okay, toluene and this one. This one is for toluene. And this one is for benzene respectively, because benzene is written first here. So this one is benzene. This one is toluene. So PA naught, PB naught given, P total you will get, PB you will get. Substitute these values here. Get the answer. So I'm repeating everything. Basically, you have to use the formula that PB will be equal to P total into into YB. From here, you have to get YB. Okay. But for that, you need PB and P total. For PB and P total, you need the mole fraction also. So you will first calculate the number of moles of A toluene will be given mass divided by molar mass. And for benzene, given mass divided by molar mass. From here, you will calculate XA and XB. XA will be NA divided by NA plus NB. XB will be 1 minus XA. You got XA and XB. From here, you will say PB equals to PB naught into XB. So from here, you will get PB. Then you will say P total will be equals to PA naught XA plus PB naught XB. This P total you will substitute from here. You will get YB, which is asked. Mole fraction of benzene in vapor phase. Next, the air is a mixture of a number of gases. The major components are oxygen and nitrogen. Approximately proportion is given 20%, 79% by volume. The water is in equilibrium with air at a pressure of 10 atm. At 298 Kelvin, if the Henry's law constant for oxygen and nitrogen at given temperature are, this is actually 10 per 7. And 6.51 into 10 per 7 mm respectively. This is mmHg. Okay. Respectively, calculate the composition of these gases in water. Think about it. Composition means you have to calculate the mole fraction. So basically, this question is talking about you need to calculate the mole fraction of oxygen and mole fraction of nitrogen. This is what is asked in simple terms. So for that, we are talking about Henry's law constant. So Henry's law constant is P equals to KHX. So it means PO2 will be KH of O2 XO2. And PN2 will be equal to KH of N2 XN2. Isn't it? So first we will write what is required, then we will see, okay, what are the values given. With that, what is the relationship? This is the relationship. So what is unknown here? What you have to get, KH is given. So XO2 will be PO2 divided by KH of O2, and N2 will be PN2 divided by KH of N2. Now, common mistake which students do, don't do if you get XO2, don't say that sum of the mole fractions here will be 1, because this is just one oxygen and nitrogen we are talking about. There is moisture also, there is methane also, other gases also, so don't add. You have to calculate both separately. Now this KH is given, this KH is given, both these are given, this one and this one. It means only PO2 and PN2 you have to calculate. If you get that, you will get the answer. So how do you calculate PO2 and PN2? Anyone? With the given information, how can you calculate? I'm saying given information is this thing. This is the given information. You will use this information to get the partial pressure of oxygen and partial pressure of nitrogen. So it means it is 20% of 10 atm. This is 79% of 10 atm. Why? Because you know that P1 is equal to P1 naught into mole fraction. That is what you know, right? P total into Y, because we are talking about in vapor phase. So we will be writing like this. So P total is given 10 atm. Okay. But remember KH is given in mm of Hg. So you will write 10 into 760 mm of Hg. This is the P total. Okay. And it will be, Y will be 20%. So it will be 0.2. 20% means 0.2. 20 divided by 100. So you got P1 means I'm considering this oxygen. Similarly, PN2 will be P total into Y N2. So it will again be 10 into 760 multiplied by 79 by 100. So you will get PO2 and PN2. You got these values. So when you have PO2 and PN2, substitute these values, get the answer. Everything is known now. PO2 you got, KH is given for oxygen. PN2 you got, KH is given. You will get the answers. These will be the answers. Okay, Devanshi.
Can you please show the next slide?
Okay, I will explain. Devanshi, is that clear or not?
Yes, sir.
Okay. Ariman, on that slide, what I explained, how to get the value of PO2 and PN2. For that, I said it is the mole fraction basically of the total pressure. When you multiply total pressure by mole fraction, you get the partial pressure. So that is basically Dalton's law, if you remember. Dalton's law was that the partial pressure is equal to total pressure multiplied by mole fraction. So as per Dalton's law, partial pressure is equal to total pressure multiplied by mole fraction. So P is equal to P total, or you can say Pi is equal to P total into Xi. In vapor phase, normally we write it as Y, so you can write Y. So here P, from that PO2 will be equal to P total, which is given 10 atm. You will convert it to millimeters of Hg. 1 atm is equal to 760 millimeters of mercury. Okay. So now we have converted this P total 10 atm to millimeters of Hg. Multiply that by the mole fraction, and mole fraction will be its percentage on the basis of, so oxygen is 20%, means 20 by 100. That is the fraction. So from here you got P, partial pressure of oxygen. Similarly, you got partial pressure of nitrogen, total pressure, same, multiplied by its mole fraction. It is 79%. So fraction 79 by 100. So you will substitute these values of P oxygen, partial pressure of oxygen and partial pressure of nitrogen. Is that clear, Ananya? How we got it? Ananya, are you still there?
Yes, sir.
Next, determine the amount of calcium chloride I is given dissolved in 2.5 liters of water such that its osmotic pressure is 0.75 atm at 27 degrees Celsius. So what is pi in terms of Van't-Hoff factor? You remember the formula. Pi equals to ICRT. Okay. I is given, volume is given. You have to determine the amount. So it means you can write it like pi equals to I. This is number of moles divided by volume. Concentration can be written as number of moles divided by volume RT. And this number of moles is given mass divided by molar mass. Okay. So you will say N is equal to given mass divided by molar mass. W you have to calculate. Okay. From there, you need to get the answer. So you can get NB, the moment, sorry, N of the solute, N of the solvent, and then you can get the answer, that is amount. So basically we have to calculate the value of moles, number of moles, and we can convert the number of moles to amount. So from here pi is given 0.75 atm. And remember, if I am using here atm, I will use the value of R as 0.0821. I is given 2.47. And I have to calculate volume is given 2.5 liters. I need to keep that liter because the units of R will be atm, liter per Kelvin per mole. So value of R will be 0.0821 atm liter per Kelvin per mole. And then temperature is given 27 degrees Celsius, means 300 Kelvin. So from here you will get the value of N, 0.75 into 2.5 divided by 2.47 into 0.0821 into 300. Okay. So do this calculation. Once you have the value of N, you will convert it to mass because you need to calculate amount. Okay. So now you have the number of moles equals to W by M. From here, W is equal to number of moles into molar mass. Number of moles obviously you will get from here. And molar mass of CaCl2, you can calculate, or is it given? No, it is not given. So it will be 40 plus 35.5 into 271, 111. Okay, into 111. Those many grams. Right. Determine the osmotic pressure of a solution prepared by dissolving 25 milligrams of K2SO4 in 2 liters of water at 25 degrees Celsius, assuming it is completely dissolved. Now, this is important. It says assuming it is completely dissolved. So you will write the equation. You will say, okay, K2SO4 will get dissociated into 2K plus and SO4 2 minus. Initially, say I have 1 mole, 0, 0. And then I will have 0, and here I will have 2, here I will have 1. So what will be the value of I? Tell me what will be the value of I. I need to check. Write in the chat box. Don't say it. I need to understand how many of you can understand it. Okay, Kasak, good. I have been doing this again and again, so I'm expecting answer from everyone. Samad, no, I'm talking about what is the value of I in this case. No, it is some numeric value you can directly calculate with the information I have written. Ariman, Sabya, Tanishi, correct. Vedant, no. Samad, now correct. Don't respond to everyone, respond to only me. Prakriti, correct? You know, I'm saying again and again, I is number of moles after dissociation divided by number of moles before dissociation. So number of moles after dissociation, total you have 3, divided by number of moles before dissociation, total you had 1. So it is 3. So by this time, I think everyone should be very clear about it. Okay. Now, osmotic pressure we are talking about, obviously we will say pi equals to ICRT. What we have to calculate, the osmotic pressure we have to calculate. So we know it is 3C we can calculate. Yes, it is 25 milligrams. So C will be given mass divided by molar mass. So we will have to calculate the molar mass. Okay. So molar mass of K2SO4 will be 2 into 39 plus sulfur plus 4 into 1664. Okay. 174. Okay, so molar mass 174. So number of moles, N will be given mass, which is 25 into 10 to the power minus 3. Remember, it is given in milligrams. So that's why I'm writing 10 to the power minus 3 divided by 174. This is N. And then I have 2 liters. So V, so I can write this equals to I into N by V RT. Substitute all these values. I is 3. N we have calculated 25 into 10 to the power minus 3 divided by 174 divided by volume. Volume is 2 liters into R 0.0821 into temperature is 25 degrees Celsius, 298 Kelvin. And you will get the answer. The answer obviously will be in the units of what we have used here. Okay. So we are using ATM liter, so it will be in ATM. Any confusion? You will not hesitate to ask during the class. But in test, if you don't get marks, I will be after you.